All right, that brings us to our summary. So, it says we can use diagrams showing lengths of rectangles to see when expressions are equal. For example, the expressions x plus 9 and 4x are equal when x is 3, but are not equal for other values of x. So, we can see that here. Here is x plus 9 and 4x when x equals 1. And we can see they start at the same place on the left, but they don't end at the same place on the right. Here's the same two equations when x equals 2. And again, they start lined up on the left, but don't end up lined up on the right. When we diagram the two equations when x equals 3, they line up on both the right and left. And then lastly, trying it when x equals 4, we again get lined up on the left, but not on the right. So, sometimes two expressions are equal for only one particular value of the variable, as we saw. Other times, they seem to be equal no matter what the value of the variable. So, expressions that are always equal for the same value of their variable are called equivalent expressions. So, if we can pick any value for the variable and the expressions are equal, they are called equivalent expressions. It would be impossible to test every possible value of the variable. How can we know for sure that the expressions are equivalent? So we use the meaning of operations and their properties of operations to know that our expressions are equivalent. Here are some examples. And these, you may remember these from a previous grade, and I've talked about them as we were doing these problems. X plus 3 is equivalent to 3 plus x because of the commutative property of addition. This states it doesn't matter what order we add numbers together, they have the same value. Similarly, 4 times y is equivalent to y times 4 because of the commutative property of multiplication. Again, if all we are doing is multiplying 2 or 3 or however many numbers together, it's not going to matter what order we multiply them in. They will have the same value. A plus A plus A plus A plus A is equivalent to 5 times A because adding 5 copies of something is the same as multiplying it by 5. And I always think of this, here you're adding A together 5 times, so it's 5 times A. And lastly, B divided by 3 is equal to B times 1/3 because dividing by a number is the same as multiplying by its reciprocal. Okay, and like I said earlier, in the next few lessons, we are going to be looking more closely at the distributive property. We saw an example of that in the Are You Ready for More?